Well, dear students, now I am going to tell you more questions about thermodynamics. Here, a gas is fixed and closed in a cylinder. The piston here loaded with spring. When the piston is released, the spring is compressed by gas. An ideal monatomic gas is confined in horizontal cylinder by spring loaded piston. The piston initially gas is at temperature T1, pressure P1, volume V1, and the spring is in its relaxed state. The gas is then heated very slowly. To temperature T2, pressure P2, volume V2. I am repeating here, monoatomic ideal gas is confined in this region fitted with piston, frictionless piston, and a spring. Spring is in relaxed condition. When gas is heated to initially from pressure, volume temp P1, V1 to T1 to P2, V2, T2. Initial pressure P1, volume V1, temperature T1. I am writing here. P1, V1 and T1, and initially the spring is in relaxed condition. Now gas is heated anyhow, then pressure becomes P2, volume V2, temperature T2, and spring is compressed by X. Then these are the following questions. Which one of these are correct? If V2 equal to T1, T2 equal to 3T1, then energy in spring is 1 by 4 P1 V1. If V2 equal to 2V1, T2 equal to 3T1, then change in internal energy of gas 3P1 V1. If V2 equal to 3V1, T2 equal to 4T1, then work done by the gas is same by 3P1 V1. D. If V2 equal to 3V1 and T2 equal to 4T1, then heat given to the gas is 17 by 6 P1 V1. So actually different authors are doing in different way, and I have searched the correct solution of my own way. So please listen. There comes question of multiple choice question. More than one option correct. It may be from that part. So gas is monoatomic. So first part A. A part says ion इसमें A part. Yes. Energy stored in spring is equal to work done by the gas. Energy stored in spring is equal to condition is that V2 2V1 है ना, T2 3T1. तो from P1 P2 V2 upon T2 equal to P1 V1 upon T1. T2 3T1 upon P1 P2 V2 upon T1 upon T1 upon P1 P2 V2 upon T1 upon T2 3T1 upon P1 P2 V2 upon T1 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 upon P2 into V2, 2V1, T2, 3T1, P1 V1 upon T1. Here you get P2 equal to 3 by 2 P1. So pressure varies from P1 to 3 by 2 P1, and force is equal to force acting on piston F equal to P into A. Since pressure varies, so it will be average pressure, average force. Average force will be P1A plus 3P2A upon 3P1 upon 2 upon 2. Average force. Then it will be 3P1A upon 4. This is the average force against which work is done. And you know work done, W is equal to force into distance. Here it is 3 by 4 P1 A into X. But A into X, if this goes to this, it is V2 minus V1 equal to 3 by 4 P1 V2 minus V1. V2 equal to 2V1 here. V2 equal to 2V1 minus V1. So it is equal to 3 by 4 P1 V1. But it is given here 1 by 4 P1 V1. So A is incorrect. And hence A is incorrect. I hope you have got my point. Here in part A, V2 equal to V1, T2 equal to 3T1. Then energy stored equal to work done. And here pressure varies from P1 to 3, P1 by 2. So average pressure multiplied by area is equal to force into distance work done. And remember, actually A into X, it is change in volume, that is V2 minus V1. Area of base into height volume. ये कंसेप्ट भी यहाँ बच्चे कंफ्यूज होते हैं. Now B part. Again, if V2 equal to 2V1, same condition, T2 3T1. Then in B part again, P2 is equal to 3 by 2 P1. Then you are asked change in energy. It is monoatomic gas. Internal energy of gas is F by 2 RT. The internal energy of ideal gas depends upon temperature. Depends upon temperature. So delta U will be F3 by 2. F3 होता है मोनोटोमिक गैस के लिए R into T2 minus T1. 3 by 2 R T2 minus R T1. And from here, ideal gas equation, P2 V2 minus P1 V1. P2 is equal to 3 by 2 P1, V2 is equal to V1 minus P1 V1. It is 3 by 2 into 3 P1 V1 minus V1. 2. So it is only 3 P1 V1. So B part is correct. B part is correct. B is correct. It was incorrect, it was correct. Now C part. If V2 is equal to 3V1, C part. This question is very simple, but in first glance it appears that how to do. In C part, again, work done, again pressure varies, so work done variable force multiplied distance. So from equation P2 V2 upon T2 equal to P1 V1 upon T1. P2 into V2. V2 3V1 upon T2 4T1 is equal to P1 V1 upon T1. From here we get P2 equal to 4 by 3 P1. So average force, we have to calculate work done, equal to P1A plus P2A upon 2, यानी कि P1 plus P2 into A by 2. P2 equal to 4 P1 by 3. So P1 plus 4 P1 by 3 into A by 2. It is 7, 3 plus 4. 7 P1 upon 2 into 3, 6 A. I hope you have got my point. By addition here will be 7 P1 by 3 into A by 2. So this is the average force against which work is done, and hence work done. Average force into distance, that is 7 P1 upon A upon 6 into X. It is equal to 7 by 6 P1 A into X. It is V2 minus V1. But here V2 is 2V1. 7 by 6 P1 into 2V1 minus V1. No, sorry, 3V1. So we get here 7 by 6 into P1 into 2V1. 2 3 are 7 by 3 P1 V1. So this is also correct. So here two portions are correct. Two answers, two options are there. Now we come to 3, fourth part. Again V2 3V1 T2 4V1. तो P2 तो हमारा फिर क्या हो जाएगा? P2 is equal to क्या भाई? Sorry, P2 V2 upon T2 is equal to P1 V1 upon T1. So P2 into 3V1 upon 4T1 is equal to P1 V1 upon T1. So P2 is become 4 by 3 P1. So work done, तो you are asked how much energy supplied. If V2 is equal to 3V1, T2 4T1, then heat given to gas, because gas was heated. So in this case, W is equal to that 7 by 3 P1 V1. Actually heat given Q is equal to W plus delta U होता है from first law of thermodynamics. From first law of thermodynamics, heat given U is doing work and is making internal energy. So what done this you have to find delta U. Delta U of monatomic gas 3 by 2 R T2 minus T1. Now which is equal to 3 by 2 R T2 minus R T1 is equal to 3 by 2 P2 V2 minus P1 V1 from ideal gas equation. But PV is equal to RT तो होता है 4 1 mole. It is 3 by 2 P1. P2 is 4 by 3. P1 V2 3 V1 minus P1 V1. So it comes 4 9 upon 2 P1 V1. 4 P1 V1 minus P1 V1 3 P1 V1 3 3 9. So now work done to is this. Now heat supplied Q is equal to delta Q कह लो whatever you like. Delta U plus delta W. Delta U is this 9 upon 2 P1 V1 plus delta U 7 by 3 P1 V1. So it is 9 by 2 plus 7 by 3 P1 V1 and it comes out to be 627 plus 14 P1 V1 is equal to 41 by 6. But you are given that it is 17 by 6, so it is wrong. So D option is incorrect. This is here a very good question. Actually, this is my own solution. I have seen the solution given by 2 books, but both are in method of solving are wrong, because here when pressure varies, work is done against variable force, or variable force either you use integration or take average force F1 plus F2 by 2. Thank you. We will meet in next